Hello, I'm Natalia Makarachkina, and thank you for joining me for this Power Connect conversation. In just a few short years, the term edge computing has become part of the language of technology. This is hardly surprising. Edge will impact virtually all of us in the workplace as well as at home and at leisure. The trade press reports that by 2025, more than 75% of all enterprise-generated data will be created and processed outside of the traditional data center or cloud. The strategy of placing data processing capacity in close proximity to the point of use is a vital innovation. It will help to ensure customer satisfaction for media companies selling streaming subscriptions for sporting events, films, and other entertainment. And it will be key to the success of Internet of Things and Industrial Internet of Things use cases, which will generate data on a scale never seen before. It will also be the enabler for many emerging technologies, from autonomous vehicles to extended reality and 3D applications. Edge computing will become a pervasive. To fully understand the breadth of the opportunity, we need the help of specialists, industry analysts. And so, it's my pleasure to introduce to you Dalia Adib. Dalia is Edge Computing Lead at STL Partners.
Hi, Natalia. I'm really looking forward to the discussion today. In terms of STL Partners, we are an advisory firm based in the UK, and we do work globally. What that means is we provide research services. We have an off-the-shelf research subscription, providing insights, market insights on different topics, mainly in the telecom sector, but we also cater to data center type companies, the IT world and technology world in general. So the topics, range from edge computing, but also things like augmented reality, blockchain, the move towards 5G, etc. The other side of our business is a consulting practice where we, in a more practical way, advise different businesses on their strategy. And our main focus within that is looking at new sources of revenue growth. So again, looking at technologies and how they can grow businesses across different sectors.
Okay, thank you, Dalia. And could you tell us a little bit about yourself? How long have you been with STL Partners, and how did you come to be the lead for Edge at the consultancy? What brought you there?
So I've been at STL Partners for about 7 years now. Before that, I had worked in startups. One was looking at mobile payments in the restaurant sector, for example. And now I'm a director in the consulting team at STL Partners, and also head up the edge computing practice. How we sort of grew the edge computing practice was really looking at things like mobile edge computing 4 or 5 years ago now, which was a telecoms industry view of edge computing. But since then, it's really grown as an area, now looking at how edge computing is impacting manufacturing customers and manufacturing solution providers in the kind of IT and OT space, doing similar things in other sectors, whether it's retail, financial services, etc. And more looking at different types of edge. So really spanning from large data centers in tier 2, tier 3 cities as we move towards the regional edge, but also looking at very small types of edge computing on the end device, like a video camera, etc. So lots of different things. It's always really exciting. And and really my role here is to kind of grow that practice, to create a bit of a community. We're doing things like creating an edge ecosystem, as we call it, where we map different companies across the edge ecosystem, including companies like Schneider Electric, and just generally engaging, various companies through events and webinars and things like that.
That's great. So you have touched a little bit on different types of edge. Maybe we can go a little bit more about the main trends which are driving edge computing.
Yeah, there are many trends. I'll try and pinpoint a few. One of them is related to, I think, what you mentioned earlier around the Internet of Things, and related to that, this idea of using data more and more to improve operational processes and decision making generally, in across different enterprises, and also the vendors who provide the solutions. And I think what we've seen in the last maybe even 20 years now is the move towards using data and collecting data, but it's been in quite a slow way to a degree, because it was this idea of just collecting data into a central data warehouse. But the challenge came about that the teams, the practical teams who needed to use that data couldn't really make sense of it, or it was it wasn't built or wasn't architected in a way that was easy to get those insights. And now there's also a need that to use that real-time element. So rather than looking at historical data, which has limited use, and being able to again inform real-time decisions, there's a need for real-time data. And what that means is that you need to be able to compute and to analyze that data as it's being collected, and that's where edge plays a role. So I think that's one of the key trends we're seeing. The second one is a little bit looking at the value chain and the way in which enterprises in particular are evaluating and accessing new technology, particularly technology related to storage and compute. And there's generally across lots of different sectors this move towards kind of disaggregating parts of the value chain. So rather than having a traditional piece of equipment where the software and the hardware is all tied together, there's a disaggregation happening where you have kind of best of breed players providing better solutions for different parts of that overall solution. There is a challenge to this in that enterprises struggle to piece those things together to manage an ecosystem of partners. So there's still a need to have that single solution, but it will probably be made up of different parts. And what that means is, because things are broken down into different modules, it kind of encourages the use of distributed or edge computing, because you're able to distribute different parts of that overall application or the overall solution in different places across different sites, different data centers, etc. That's the second thing. I think the third thing that we've seen, which you can't ignore when you talk about edge computing, is the move towards the cloud. Again, started off relatively slow, but we've seen that pick up very quickly in the last, especially the last 2 years with the pandemic and the move to work, towards remote working and everything going online. That's put a lot of pressure on increasing data center and cloud capacity, and also making it more flexible, more accessible, ensuring it's always reliable, that sort of thing. And I think what again enterprises have found is that the centralized cloud is great for solving a vast majority or a vast number of use cases and situations. But now what enterprises are interested to do is use some of those capabilities that come with cloud. For example, the flexible commercial models, being able to scale up compute capacity up and down, the tools that come with it, whether it's the great cloud platforms that have materialized as a result, machine learning tools, developer tools, etc. Things like CI/CD, the actual operating models behind developing applications. That's all being great stuff, but it can't serve the needs of all use cases if it's highly centralized and operating from a remote data center. So for that reason, there's this trend of distributing that compute, so allowing enterprises to use cloud-like technology, but on premises, at the edge, even on the end device, again in smaller data centers within a specific region, to be able to use those tools, but also ensure that data is secure because it's within a certain jurisdiction or within the campus of the enterprise, that it's low latency as well to meet the needs of specific applications that just can't run in a remote cloud. So that I would say that's the third trend. It's a pretty mega trend, and it's all around this general view that edge is an extension of the cloud, and it's really a distributed cloud that we're looking at. And as I said, there's lots of things going on around these three trends, but I would say those are some of the three key trends that we're seeing.
Thank you. A really detailed answer to the trends, and I think very interesting. Now let's look into 5G and edge computing. Would you say that next generation high bandwidth and low latency mobile communications are a critical success factor for edge?
Yeah, it's quite an interesting question, and I think the two are definitely interdependent. We always say that 5G needs edge more than edge needs 5G. And there's a few reasons for that. One is that the 5G network is inherently built on kind of IT standards and edge computing infrastructure. So what that means is that, rather than traditional, say, telecoms equipment being used to build different parts of, say, the 5G radio access network, or again, different parts that control and manage the network, it's going to be built on, servers and IT infrastructure. And a lot of that is going to be at the edge because it's, within the telecoms network. So physically, 5G, needs edge, first of all. I think the other thing is that, the two have complementary benefits. Both together are able to, achieve lower latency to help end applications function better, improve performance. 5G brings, quicker speeds by optimizing the pipe itself. What edge computing allows the application to benefit from is actually shifting that application closer to the end user or to the end device, so that the distance that the application has to travel is much lower, which again, helps with latency. But there are things that, edge computing can bring that 5G can't bring. So, I mentioned things like data security, data sovereignty, big trends, enterprises and governments becoming more aware and, putting more, I guess, rules and policy together around where data can be hosted. And that's really about, physically, again, where the data is. And that's what, edge computing can help to solve. There's also, say if there's challenges around bandwidth, again, that physical change in where the application is hosted can reduce that distance and therefore reduce the amount of bandwidth required, and then, avoid having to rely on maybe an unstable network. So complementary, but, edge computing can bring things that 5G can't. And I guess related to that point is that, edge computing is not a 5G based technology. You can connect to an edge compute over Wi-Fi, over a fixed network. We're seeing even cable operators in the US, invest in edge computing who, don't have a 5G network in some cases. You're seeing edge computing in campuses. So whether it's a manufacturing site or maybe even an office block within a building, or, a shopping mall, for example. And often those devices are not going to be connected over 5G. So there's going to be lots of interesting use cases where 5G is required and it is the main connectivity technology. But, probably a larger part of the market looking at non-5G use cases that will be enabled by edge as well.
Okay, so we can say that 5G and edge are interdependent on each other, right? So 5G will require edge, and edge will require 5G really to be successful. Okay, now let's talk a little bit about edge application. How do use cases differ between different types of edges or industrial segments?
Yeah, so it's a fairly big question. I'll try and, I guess, explain my view of the world. So if let's look at the different edges, and I can, weave in how the industrial segments, the use cases fit into these different edges. And the way we like to talk about it is kind of in order of where the edge is in relation to the end device. If you take the furthest edge from the end device, which is what we call the regional edge, that's where you have still the edge looks like a data center, but these will be smaller data centers in I think I said tier 2, tier 3 cities. What we mean by that are definitely smaller cities. It could even be rural areas where at the moment there isn't really data center capacity in the city, or it's also that the nearest data center is quite far from a latency perspective. So you might get over 200 milliseconds of latency, so the time it takes for the application, to go to the data center and back. That's over 200 milliseconds, and that's noticeable even, by the end user. So what those regional data centers are being used for, or the regional edge, it's things like just reducing that latency. So you can't probably get it down to 10 millisecond round trip, but you can at least have a more consistent, sub 100 millisecond latency. And that's good for things like video content streaming. So you can store local content in those regional edges to optimize video streaming platforms. You can also use that same kind of technology for gaming as well. And as we move towards cloud gaming, that's a big trend, and gaming companies are taking, fairly significant portions of those regional data center spaces. And then the other, I guess, type of use case or trend, let's say, related to that is also, again, the data sovereignty. So in the US, it's really interesting because you're seeing states imposing different data kind of storage and security regulation. And that's that's increasing complexity for the enterprise as well, because they're having to store data. Again, think about their data architecture in a different way and store data of the consumers from one state in one data center, and in another state in another data center. And then there are some states which may have more lax laws, and so can use more centralized data centers. So that's another, I guess, use case related to that. The second type of edge is what we call the network edge. So these are the edge data centers which are on the mobile or on a telecoms network, could be mobile, could be fixed. They are essentially they are physically in the facilities within the network that is used to put in the telecoms equipment. But that telecoms equipment, like I was saying, is moving towards more server-like, IT-like infrastructure. And so the building itself is becoming more like a data center. And telecoms operators are opening up that environment to not only host their own network infrastructure, but also use it to allow enterprises and cloud providers and others to put in their kind of IT equipment and offer edge services off the back of those data centers. And the use cases that are sort of being touted as early adopters or interested parties around the network edge are things like augmented reality, virtual reality, now kind of being used or being termed as the metaverse. So being able to render the augmented reality content from a network edge is helpful because it reduces latency, and it's got a low enough latency to meet the needs of that type of application. Again, gaming. So as gaming becomes more complex, you have more complex imagery, you may not be able to use those regional edge data centers, and you might need an even lower latency, and that's why you would use the network edge. And we've seen some use cases also in the transport sector, because the cars are moving around, so they need to be able to use an edge that can move with it and can also, again, meet those latency needs, and that's where the network edge is interesting. Then we've got the third type of edge, what we call the on-prem edge. Sometimes it's called the enterprise edge as well, or campus edge. Basically, it's edge computing at the actual on site, and so you're seeing this a lot in the manufacturing sector with IT, OT convergence, and the move towards using IT infrastructure for things like operational processes, for measuring, using video analytics, for example, to measure quality, to use it for automated guided vehicles, so the robots that move supplies across the manufacturing site. Some of that processing is happening on an edge compute. Seeing it in the retail setting as well. Again, some kind of video analytics applications, which I saw one actually recently, which is quite interesting, using video analytics to to kind of test or to evaluate someone's age for supermarkets. When you have to buy items which have a restricted age policy, so being able to, I guess, reduce false positives by using video analytics is the real application we're seeing. And then the last type of edge is the device edge. So that's edge computing on the end device. The main type of device we're seeing here is like a camera. So rather than a camera being quite dumb and just collecting data, a camera can become an edge compute device if it's able to use the compute capacity on the camera for other applications, and almost gets configured as if it was a processing unit, a server. So you can swap in and out applications. There's some kind of software, hypervisor software, to be able to do that as well, rather than it being fixed for its one specific purpose. So that's a bit of a controversial edge, because depending on where you sit in the edge spectrum, some don't include the device edge, but I think it's important to acknowledge it. And there's lots of innovation happening from manufacturers of chips, basically, so in semiconductors, to make the device edge quite an interesting form of edge and really do more with those end devices as well.
So I've almost answered my next question, because I was about to ask about any new applications which have been deployed recently. If you have something to add to what you have already described, it would be also great, but I think you have already covered many examples.
Yeah, I think definitely. I mentioned a few of slightly more futuristic ones, like augmented reality, virtual reality. I would say we're pretty early days with the adoption curve of those types of use cases. But the other groups that that I think is getting traction is around video analytics, and that is a large or very broad, let's say, segment of use cases. Mention things around using video analytics for quality control and manufacturing processes. The reason why it's so interesting for edge computing is because it's been difficult in the past to be able to use video cameras as a sensor and be able to collect data, because that's very high bandwidth. It puts a real strain on the network, and it's quite expensive to do so if you have a more centralized kind of cloud compute environment. So edge computing opens that up. I think the nearer term, some of the interesting ones that came out of the pandemic, which are nearer term, are things like using video analytics to comply with health and safety kind of rules and regulations. So some of the ones I've seen are things like using video to monitor if employees are social distancing, or if they're wearing, say, hard hats in a construction environment. There's, other things that we've seen related to video analytics, which are around access control. So, rather than using, say, a key card to get into your work, using video analytics and doing that, the compute to take your biometric data and check whether you are an employee or not needs to be done on the edge as well. So video analytics is a really big one that we're seeing come about. I think there's a few other maybe more niche use cases that we're seeing. One fun one that I've seen that I think Verizon is testing at the moment are things like using, I think it does use video, but also other sensors to monitor players. So I think it was either a basketball kind of scenario, basically any sports match. You've got sensors, around the stadium, around the pitch, and you've got sensors on the players as well. And basically, it's really about knowing what's happening in the game at a really granular level. And part of that is for the geeks and fans who want to learn more and to maybe create more customer or fan experiences from that. But then there's some other use cases using that data around things like betting and real-time betting and optimizing that that's coming about as well. So basically lots of different things.
Okay, thank you. Now let's talk a little bit about ecosystem. As you know, at Schneider, we're finding that today's customers expect technology vendors to collaborate and solve challenges of integration. Do you think that ecosystems will be important to the rollout of edge? Who are the key partners required to enable an edge computing solution? And how do you think the ecosystem for edge computing differs to cloud?
I think the ecosystem for the edge is definitely different to the cloud. I think there are some players who are going to operate in both and have similar roles. Like for example, you've seen the cloud providers extend their offerings to provide products and solutions at the edge as well. But they are fundamentally different. I mean, first of all, the edge is physically distributed, and that means that you have, like I talked about before, you have different types of edges, and that means that it's very difficult for one company to provide a solution that's going to work for every single type of edge, because the edge at that at the end device and the video camera is entirely different to the edge data center, which is in the tier 2 city, for example. So that's one thing. It's different. Second of all, as I said, it's distributed. So you're going to have, rather than a very centralized form of infrastructure, you have tens, if not hundreds, of edges for each enterprise, and they are going to have an edge that might be built into the end device in one store. If you think about a retailer, let's say, then they've got maybe some retail shops in a city where they're very well connected and they can access a central data center. Then you may have other stores which are really remote. You've got warehouses as well within a retail store has to or retail brand, let's say, has to manage, which will have a different type of edge. They may have that on-prem edge that I talked about to help them implement robotics, let's say, in their warehouse. So it's very different, and the use cases as well are very different to the cloud too. So the cloud, at least at the beginning, was really about moving IT workloads from data centers that customers owned or more traditional data centers to cloud data centers. The edge is kind of serving use cases that are, some of them are in IT, but a lot of them are not. And they are mission critical, much more mission critical use cases that are, enabled by edge than the cloud. Robotics being one of them. You can't have a robotic arm fail or fall on a manufacturing worker or engineer in a plant. That's it's very critical to the running of the plant. Similar things in telecoms. You can't have the radio network not work, which is resting on edge computing platforms. So there's a kind of a higher level of criticality, and that again means that the vendors and the ecosystem that serves it is very different to the cloud as well. So in terms of the key partners that are actually required to enable that edge computing solution, I think you mentioned early on about that need to integrate, and the fact that an ecosystem has to be pulled together to deliver a solution. And I think that is one of the parts where partners play a key role, is doing that stitching, because although enterprises, they are moving towards new technology, they're changing their operating model, their business model, their skills in-house, so that they can, upgrade and get access to those, new cloud and IT and data analytics skills. They don't want to spend their time on creating solutions or integrating solutions. They want to spend their time on their core business, basically, and creating new products and improving processes, etc. So that's why I think partners play a key role, is taking some of that burden off their customers and making sure that although they can bring best of breed parts of the solution, that they don't then add costs and further challenges for their customers to implement that. And I think it's quite early days where we are on the edge, that the adoption curve. So that's still being worked through, I think, and it's still, we're still trying to understand who plays in which part of the value chain, and which company is sort of really investing in that, and which companies are going to vertically integrate and do more of a full end-to-end solution type model. But I think in the next couple of years that's going to play out, and then we're going to see more of those those blueprints, those ready-to-go solutions that customers can implement. And I think again, somewhat related to that point, is not just doing that, not just integrating and implementing something for a customer in one site, but being able to scale that, and again optimize the operations of a scaled out edge deployment. So when a customer wants to repeat an edge deployment across different sites or for different use cases, and has to monitor new edges, that needs to be done in a centralized remote way, so that they don't add costs, operational costs, by having, say, field or operational engineers at each and every site. So that's another, I think, key place. But essentially each partner across that ecosystem at the end of the day has a part to play, whether you're the hardware manufacturing providing the compute resources, or you're the application, the independent software vendor providing the application that's say the robotics application, or the AR application, augmented reality application. Everyone's got a role to play, but I think those around integration operations are going to become increasingly useful as we move to this next wave of edge, and enterprises start really building out their edges and scaling out edge-enabled solutions.
Okay, thank you, Dalia. As you know, Schneider always believes in the ecosystem. We have great ecosystem with our partners, but also with our alliances. We are talking about our joint projects with Lenovo, Dell, HP, and many other companies. We're also looking into prefabricated data centers, including a micro data centers with specific liquid-cooled edge infrastructure for harsh environments. And I think that will be more to come for sure. And is there anything else, Dalia, I have not asked, and you want to add maybe something you think is important to share with our audience?
Yeah, I think just reiterating, when I talked about scaling deployments, I think it's just going to be exciting to track those and to see more examples of that, because we haven't seen so many, edge deployments where you see a customer implement it across multiple sites, say, or multiple different countries. So that's going to be good to keep an eye on in the next year or so. I'm also interested to look at what, how edge is shaping up in different parts of the world. I think there's been a fair amount of traction and investment going on in, North America and Europe, some parts of Asia, but I would say, less so generally. So that is picking up. I've heard from telecoms operators, from data center operators and others that there is kind of increasing demand, undoubtedly in data centers in markets like Asia, but now moving into edge computing as well. And I think, the other thing is the pressure to deliver edge computing in a more sustainable way, especially as you have an opportunity to with a kind of more greenfield environment. That's going to be, baked into it, and seeing a lot of innovation from, in the power and cooling side that, Schneider Electric, I'm sure is part of. Just in, again, on the chip side, on the, processor side, to be able to make them more dense, but try and optimize the use of power more. And then, again, that's going to be a bigger and bigger theme over the next few years. So we anticipate we'll be covering that more as well as a topic.
Thank you, Dalia. It's been fascinating talking to you. Thank you for joining me and sharing your insights and experience with us. And to you, our viewers, thank you for joining today's Power Connect video. I hope you found it useful, and I look forward to seeing you again soon.